Hi, everyone. My name's Andrea, and I'm a content marketing specialist here at Vultr. In today's Tech Talk, we're going to explore ways to package machine learning models as containers for easy deployment. So tune in and learn more now.
Hi everyone, my name is Mayank and I'm the head of developer advocacy here at Vultr. And in this webinar, we are going to talk about how to package machine learning models as container images. Containerizing machine learning models for deployment allows you to deploy it on environments such as Docker and Kubernetes. You can store these container images in private container registries such as the Vultr Container Registry. It gives you the benefits such as being able to reproduce the environment required by your machine learning models such as the CUDA libraries, and it also makes it portable and scalable. You can spin up a worker node whenever required in any of our 32 data center locations to serve your incoming traffic. It also gives you isolation so that you avoid any conflicts between the running applications. Hugging Face text generation inference is one of the solutions you can use to containerize large language models. It supports all the major large language models such as Mistral, Llama 2, and many more. It comes with optimized inference code to make LLMs go faster and a request buffer to store all the incoming requests and serve them as soon as the model is ready. With support for safe tensor weights and tensor parallelism, you can use it with multiple GPUs and it supports quantization and fine tuning. We also have a demonstration coming up after next few slides and you will see how you can use this. Next up, we have VLLM, which is a very similar solution to Hugging Face's text generation inference. It also allows you to containerize large language models and use them as an inference API. There are similar features such as a request buffer and tensor parallelism, which will allow you to serve as many incoming requests and use multiple GPUs. But it supports optimized CUDA kernels and paged attention, which will allow your LLMs to perform faster in some instances. It also has an OpenAI compatible API, which will allow you to swap out some variables in your GPT-4 code, and VLLM's inference API should just work fine. The main problem with Hugging Face text generation inference is the restrictive license, but VLLM, on the other hand, comes with a Apache 2.0 license, which will allow you to use it for commercial usage. Apart from working with large language models, you can also use a solution built by BentoML named OneDiffusion to spin up inference APIs with image generation capabilities. It has broad compatibility and supports the recently released Stable Diffusion and Stable Diffusion XL turbo models by Stability AI. It has optimized performance and support for dynamic LoRa adapters so that you can use it with fine tuned models. It shares the license with VLLM, which is an Apache 2.0 license, so that you can use it for commercial purposes. In the previous slides, we talked about various pre-built solutions you can use to spin up an inference API, and you will see that in the demonstration coming up next by Mridul. But there is documentation available if none of those pre-built solutions fits your need. You can also build your own inference API and you can find the documentation for them on Vultr Docs. Here you can see two examples of building an inference API with Fast API, Hugging Face diffusers, and Hugging Face transformers. You can find the link in the description down below.
Hi everyone, my name is Mridul Swaroop, a developer advocate here at Vultr, and today I'm going to demonstrate Hugging Face Text Generation Inference, VLLM, and One Diffusion. To use Hugging Face TGI, VLLM, and One Diffusion, first we need to deploy a Vultr server. So let's click Deploy Server. Here we need to choose Cloud GPU as a server type and A100 as a GPU type. You may select any location according to your preference, and I'm going to be selecting Bangalore, India. In the operating system, we need to select Vultr GPU stack with latest Ubuntu. One of the most important benefits of deploying a server with GPU stack is GPU stack come pre-installed with Docker and softwares like Jupyter Lab, which can really speed up our development times. So let's move ahead and select a server size. 80 GB GPU RAM server is enough for us to demonstrate the three methods. And scrolling downwards, you may select any option according to your preference. And let's click deploy now. To save up some time, I have a Vultr server here already deployed. At first, I am creating two environment variables, where one is for the model, and the model I am using is Mistral 7B by Mistral AI, and the other variable is for defining where I will be storing my model weights. Now let's run Hugging Face TGI container. Here you can see we are giving the GPU access to the container by giving the GPUs all flat. Custom Docker containers, you can use this Docker container as a base layer and build custom containers. As you can see, the container is being downloaded from the GitHub container registry. Now, once you see connected in your console, that means the model is up and running and you can infer the model to generate responses. To infer the model, you have to visit this endpoint where you have to type in your IP address, the port at which your Docker container is exposed, and the docs endpoint. This is the inference user interface for the model. Here we will send a post request to the model. Let's click try it out. Give it a custom response. Vultr is a cloud company. The model will try to finish the sentence we have started. Let's increase the max new tokens to 100 to get a proper response. Let's click execute. Scrolling down, there we have it. The model has completed our response by typing in 100 tokens. This was the Hugging Face text generation inference implementation on a Vultr GPU stack. Now let's implement VLLM using a Vultr server. For VLLM, I am creating two environment variables similarly as I did in HFTGM. Here also I am using Mistral 7B LLM. Now let's run the VLLM Docker container. To create custom containers, you can also use this Docker image as a base layer. Once we see that UVCon is up and running, that means we can now infer the model using a web API. To infer the model, you have to type in your IP address, the port at which your Docker container is exposed, and the docs endpoint. Here, we will be sending a post request to the completions endpoint. Let's click try it out. And here you can type in your custom prompt. So I will be replacing this prompt by a custom prompt. Here I am telling the model to complete the sentence Vultr is a cloud company. Let's click execute. And the model has produced the custom output. This is the VLLM implementation using Vultr GPU stack. Now let's see how we can deploy models using OneDiffusion on a Vultr server. For the OneDiffusion implementation, first we will install OneDiffusion on our system. Let's type in pip install OneDiffusion. I have it already installed on my system, so that's why it's showing me requirement already satisfied. Now using the build command, we will deploy a stable diffusion XL model by creating a bento. Using the command given to us, now we will containerize the model, and the containerization process can take up anywhere between 5 to 10 minutes. Now once the Docker container is created, we will run the Docker container and make sure to provide it all the GPU access it requires. Once the pipeline components are completely loaded, that means we can now infer the model using the web API. For accessing the web API, you need to type in your IP address and the port to which your Docker container is exposed. In the web user interface, we will be sending a post request to the text to image web endpoint. So let's click try it out. Replace the prompt with a custom prompt which says a blue vulture over the clouds. Let's click execute. The image processing can take up to 5 minutes. Once the image is produced, you can download the file. Here is the generated image which shows a blue vulture over the clouds. This is how you can implement one diffusion on a vulture server.
Hope you liked the demonstration. Thank you for watching this tech talk. Looking forward to see you in the next one.